Hello, in this tutorial I will show you how to use online application to automatically create point effects in your crystal structure, and these point effects can be either interstitials, vacancies or substitutes. So to use it you have to navigate to this site XRDlicious pointeffects.streamlit.app, and the link will be also in the description of this video. And then you just need to apply your crystal structure file, which can be either in a CIF format, postcard format, or in a LMP format from LAMPS. So I have here an example of alpha titanium, and I will just put it here, and to see that it was correctly uploaded, I can visualize the structure also in this environment. And yeah, this is the structure that I wanted. So you can either directly upload your crystal structure file, or you can here also browse in 3 databases: materials project, AFlow or COD, and you can directly add the structure that you will find in these databases into this application. So for instance, if I want to use alpha titanium from materials project, I can search by elements here, search for titanium, and then I would select the hexagonal titanium and just I would add it here into this application with this button. Okay, but I already have it, so let's skip that. So I can change also the cell representation here. So now I have the conventional cell of titanium, but I can create an orthogonal cell which looks like this, or I can also create different cell representations with different cell reductions. So in my case, let's just use the conventional unit cell, and then let's suppose I want to create supercell 2 times 2 times 2. So I will set it here and apply. Okay, so this is now my supercell of alpha titanium, and now I want to create here certain point effects. So let's start with inserting interstitials. So let's say I want to insert nitrogen, and for instance 4 atoms. So first I can preview the interstitial sites, which it will calculate in this structure. So here I have 32 equivalent possibilities or sites for tetrahedral coordination of the potentially inserted nitrogen, or I have here 16 equivalent sites of octahedral sites for the interstitial, and I can choose if I want to either insert these nitrogens into specifically one of these 2 types of interstitial sites, or just randomly select certain type. So if I want to select it randomly, I need to put here number 0, but if I want to select only the tetrahedral interstitial sites, I need to put here number 1, and then I can click this apply interstitial structure, and soon it will be done, and I can preview how the structure looks like with these interstitials. I can also determine a new space group for this structure, and I can try to find let's say simpler unit cell which will represent this structure object, and then I can download this structure with interstitials in different formats. I can download it in CIF, VASP, LMP, XYZ. So for instance, if I want just save, I will click this button, it will prepare the download, and then I can save the sieve with this button. Okay, so now I can reset these defects. And so this first option, how to create interstitials, is based on Voronoi method, which takes some time to calculate. And if you want to insert the interstitials to some larger structure with more atoms, it can take a lot of time to calculate the available sites. So in this case, if I have some larger structure and I want to just insert interstitials to some likely available positions, but randomly and quickly, I can select this fast grid method. And so just to illustrate, for instance, let's create 5 interstitials now. And yeah, it looks like this. So I can download this one structure, or I can also generate more structures at once with random seed. So for that I need to enable this batch mode. Then I need to select how many random configurations I want to create. I can modify the starting random seed, and then I will just generate multiple defect configurations. So I can create 10 times random structures with 5 nitrogen interstitials and download all of them in a zip. So I will save it, and now I can extract it and just show you that it is what I wanted. So I'll put these structures into Ovito, and you can see they are different. They have different sites occupied with nitrogen. So this is it created what I said I want to create. Okay, so this is the option for creating interstitials, and then I have here options to create vacancies. So let me reset this structure, and okay, and batch mode. The batch mode is possible for all defect operation modes. And in case of vacancies and substitutes, I have here option to place these defects either as far away from each other as possible, or nearest as possible, or like at some moderate distance, like between these two options, or completely randomly. So let's say I want to place like 20% of vacancies, so 3 atoms will be removed, and place them as far away as possible in this structure from each other. And I can select which algorithm to use. So like the reasonable fast one is this greedy one, which starts like from one defect. Randomly it will create one defect, like 1 vacancies. Then it will calculate like the farthest atom from this defect, and it will create a new vacancy on that farthest place atom, and then again from this second defect, it will calculate the third farthest atom and place a third defect on it, and it accounts for periodic boundary conditions. So okay, I will apply this defect operation. So this is very quick, and okay, now, and yeah, it placed 3 vacancies farthest from each other. If I reset it, okay, let's just reset, and let me illustrate you the last option. So for the substitutions, In this case, I have originally here only one element, titanium, so I can replace only one. If I have more elements, I can separately replace each element with a potentially different substitute. So for this case, let's create again 20% of substitutes with nitrogen, for instance. And now just for illustration, let's place them nearest as possible. So supposing they creating some clusters, and yeah, you can directly see they are placed close to each other. Just to illustrate again more, if I select this farthest and apply, okay, I forgot, I need to set again this 20% because I resetted everything. So apply, and yeah, you can see, considering this supercell, which is kind of small, they are placed as farther as possible. And again, I can create a batch. I can generate randomly like more configurations of this same defect concentration. And when I created this, I can here select in which format will be the downloaded structures. So like for the batch mode and for the single structure, it's here. Okay, so I think that's all to show you for this application, which just serve for creating automatically the point defects in any crystal structure. And I hope this application will be useful to you, and you can also try our main application, which is called XRDlicious.